Hello everyone, we are Team 12A of the WPI VIBE Program, and our project is to develop a low-cost portable centrifuge to diagnose anemia. These are the members of our team. Now on to the project.
Anemia is a condition that causes the body to not have enough healthy red blood cells. Red blood cells are important because these have a protein called hemoglobin that is responsible for carrying oxygen to the organs. The most common types are iron and vitamin deficiency anemia, and the symptoms are feeling tired or weak, shortness of breath, skin becomes pale or yellowish, dizziness, and headaches. There are many different types of anemia. The treatments are very different, but it usually consists of taking supplements or making changes in your diet. Africa is one of the most affected continents in cases of anemia. There are two groups that are very affected. The first one is children below the age of 5 and the second one is women. The main reason is based on malnutrition and lack of iron in their diets. There is 60.2 prevalence of anemia in the African region for the children and 42.17 prevalence in young women in the sub-Saharan Africa.
Anemia is difficult to diagnose because it has many causes. The symptoms are often masked by other underlying conditions. The current method to diagnose anemia is to determine if the patient had a low red blood cell count. This is done through a hematocrit test, which tests the percentage of red blood cells in whole blood. The test is done by separating the red blood cells from the whole blood in a centrifuge. The problem is that centrifuges are expensive and most require electricity. This makes them inaccessible in rural Africa. Therefore, we were tasked with designing our own centrifuge. Our design must be portable, capable of anemia diagnosis, usable in a low resource setting, cost under $50 total, require minimal training to operate, and be effective at diagnosis.
To ensure our design's success, we set the following parameters. Our centrifuge had to reach a speed of 3,000 revolutions per minute and maintain that RPM for a minimum of 10 minutes. Keeping these goals in mind, we set a range of plus or minus 200 RPM for the centrifuge. The only requirement for time is that the specimens must be spun for a minimum of 10 minutes. To obtain these specifications, we worked to modify the gear ratio in a common hand crank egg beater and create a test tube holding rack with a larger radius to reduce the revolutions per minute and avoid fatigue.
Our product design is based off a hand cranked egg beater. The gear system in our design amplifies speed up to 10 times of that of a user input. Furthermore, the hand crank has been incorporated into our product to allow for usage in situations where cost is the primary concern. To further address cost, we have incorporated a handheld design. However, if customers are willing to pay extra, we include a 3D printed stabilizing model, which can be assembled on site. Furthermore, the platform to hold test tubes is also 3D printed and can be easily replaceable by other circular objects according to the specification. Our model remains modular. This means that the hand crank can be replaced by a DC motor, such as those that can be acquired from toy cars, or perhaps the test tube base can be reused with material that is locally sourced.
Lastly, these are the references we used. Thank you for watching. Feel free to leave your feedback in the comments below. Have a nice day.